This conference will now be recorded.
And as part of that, we had started a discussion last call about latency requirements for 5G networks. And are hoping to continue that discussion at a later date. If you have any contacts for people that in particular are going to be trying to write applications for 5G that are latency sensitive and sensitive to latencies in the various parts of a 5G network, and we're looking for some people to come do presentations about that sort of thing. It's kind of along the lines of what are the requirements for autonomous vehicles if they're going to communicate via 5G, or factory automation where they're within a large factory space. It's going to use 5G instead of Wi-Fi. So that's an area of interest. If you have any contacts, please, or people or organizations that are involved in those sorts of 5G applications, please let myself or Marco know. I think if there's no other topics, we'll jump to allowing Goofy Space team to take over presenting their contribution to OCP.
Great, thank you. Yeah, so let me go ahead and share my screen. But before I do so, I saw Michael from OCP is online. Hey, I just wanted to take a minute and say hi. Hey, Michael, good to talk to you again.
Hey, how are you?
Great.
See you guys again. It's been a few months.
I know, it's been a few months, yeah. Say hi to your good old friends. And okay, let me try to figure out how to share my screen. Never used this tool before.
And there you go. We're seeing your slides.
Oh, okay, wonderful. Let me put that into a full screen mode here. 1 second. All right. Go to meeting has something pop up on my screen, which is blocking a portion, which is okay with me, but I want to make sure it's not showing up from the audience. You guys see that?
So actually, Kai, only you see that. We don't view it. We're only seeing your slides.
Oh, okay, wonderful. Okay, all right, yeah. And I trying to get rid of that, but then it pops up and asks me if I want to shut down go to meeting. So I say no. All right, great. Let's get started. Okay. Good morning, good evening, everyone. My name is Kylie. I'm the technical director from UV Space here in San Jose, California. We have a couple of team members joining us here in the US and also from Taiwan as well. And today we want to present our contribution of cell site gateway router to OCP. This is our second contribution on cell site gateway. About 18 months ago, we worked with Michael and we did our first contribution of our Kurman AX, known as the S9500-30XS. And today we are contributing three more platforms onto the same product family. And those are our continuation with the Kurman AX, which we'll go into all the technical detail. And then also we are coming out with two other platforms based on the baby version of the AX, known as the Kurman UX. And those are from the same family of merchant silicon from Broadcom. And for those of you who are interested, maybe I'll just spend a couple seconds on the entire merchant silicon with respect to the product line today. The Kurman came out around 2018, and the whole family were with the largest one, which is the Kurman MX, and then the AX, and then the baby version is the UX. UV Space adapted the Kurman AX back in about 3 years ago with our original cell site gateway design. And then this DAS22XS is a respin of the original AX, but we lower the port density on the device so that we can serve the tier 2, tier 3 type of carrier in different parts of the world. And so we lower the port density. As a result, we can lower the price entry point and still preserve the processing power from the Kurman AX. And then later on, we also we do an entire design based on the baby version called the Kurman UX. Same family, but they are the smallest and less expensive chipset on that Kurman family, known as the UX. And then we built two platforms, known as the 9501, 28, and then also the Dash 18. And then again, the whole idea was driven by the business requirement, so we can build something to fit better into the tier 2, tier 3 type of carrier with the lower entry point. All right. So let's talk a little bit about the distributed cell site gateway. So there's a lot of good reason why the industry is doing this, why we are doing this, why we are, working with OCP and other open foundation on this. And it really summarized into 2 or 3 key points. And basically, with the disaggregated approach, customer has a lot more flexibility on the combination of the hardware and then the network operating system, and result in quite a lot of financial saving on the CapEx and OpEx. And I really like to emphasize the OpEx over the CapEx because, we do get a lot of feedback from customer. The OpEx saving has been very attractive, not to tie into a single maintenance service contract with a, one size fit all kind of OEM solution. So that the financial side drive the disaggregated model. And then why cell site gateway? And that actually is something our marketing team has done a lot of research, and carrier just feel a lot more comfortable to start from the edge before they evolve into the aggregation and into the core. Is less vulnerable starting from the edge, so that actually drive a lot of behavior of the disaggregated model starting from the edge as the cell site gateway first, other than into the aggregation, into the core of the network. So pretty much it's summed up with the 2 or 3 key points I want to point out that, why disaggregated and why disaggregated cell site gateway, to summarize that. And then this is the first box we would like to contribute to OCP today, and known as the S9500-22XST. And as I mentioned, about 18 months ago, we worked with Michael and other folks from OCP. We contribute our original device of the S9500 family. That one is known as the Dash 30. And this one is a respin with the Dash 22, meaning all the ports add up together. We support 22 port as compared to a higher density of the original box we contribute. The design are pretty much exactly the same. The layout is a 1RU with the power supply on the left. Everything is accessible from the front because it's easier for the operator and the telco maintenance team to access everything when they get to a cell tower facility. The only thing on the back is the fan tray, which is something we support the front to the back airflow. From the left to the right, we start with the dual power supply. Mainly, most of the use case are DC. We do support AC for lab development purpose. And then moving right hand to the power supply, we support a number of the clocking options. And the most widely used one are the GNSS, which is one of the SMA connector you see on this box here. The majority of our customer today deploy this primarily using the GNSS clock, known as the GPS clock, which there's a connection go up to the GPS antenna at the local cell tower. Now, during any severe market weather condition, snow, storm, things like that, if the GPS antenna cannot be locked in, the box is designed to do a switch into PTP timing, known as the IEEE 1588 version 2 precision timing protocol. And our design from UV Space has support something called the Class C, C as Charlie. Class C basically say in an average, we can switch GPS clock into PTP clock in about 10 nanoseconds, with the worst case no more than 30 nanoseconds. And other SMA connector that you see here on the on the diagram, we support a number of legacy clock. These legacy clock include like time of day, 1 PPS, and things like that. They are there for two reasons, reference clock and also for backward compatibility. And then moving on to the right-hand side, we have a number of ports on different speed, such as we have 4 ports supporting 100 meg/1 gig, RJ45. Those are for some of the legacy BBU connection. And then after that, we support another 8 port with different speed, 100 meg, 1 gig, 10 gig with SFP for legacy BBU. And then moving on to the right-hand side, we have some higher speed that we support for the more modern BBU. And then last but not the least, on the right-hand side, those are the dual uplink to support the uplink from the cell site gateway. Usually it goes up to a metro Ethernet, and then eventually it hits the aggregation of the entry point into like a central office. So those are the dual uplink. And I should mention something about the dual uplink. Originally, Crewman AX or other family members, this chipset, they do not support MACsec, the medium access control security, the layer 2 security. Our box actually does, and in a second, I'm going to show you the block diagram because we have added another Broadcom chip just for the 2 uplink port to support MACsec security for those who may be needed. Another thing on this box, the data plane, as we mentioned, is the Crewman AX, and then the control plane is Intel Broadwell 4-core 1.5. We have a different processor to take care of all the other housekeeping, known as the BMC ASP20 family type of CPU. And in a second, I'm going to show you all these other breakdown of the design. So this is the block diagram of the design of the box that we just showed. We color code them. The blue are the data plane, which is the Crewman AX. This is the same design as we contribute of the other cell site gateway a while back, 18 months ago. One thing I want to call out is the Crewman AX in the blue color. We are also running the broad PTP processing to provide the PTP timing. And then the green is actually a external digital phase lock loop from IDT, Integrated Device Technology. And the reason we need a external DPLL is because if you recall the original slide we showed, we support about 5 or 6 different clock sources, and each one require a timing connection that goes into the data plane. The data plane Crewman UX has a built-in digital phase lock loop chipset inside this Crewman AX, but they only provide up to 2 pin, meaning we can only support 2 clock source. So as a result, we had to utilize an external DPLL to kind of like fan out and aggregate all the different clock sources. And that's what the green block is. And then moving up to the left upper corner, the kind of the orange brown color, that one is our control plane, is the Intel Broadwell CPU. And then further down, that's kind of the orange smaller block with the AST2400. That is our BMC processor to control all the boot up, such as the LED, the RPM on the fan, the regulation, the voltage regulation, making sure the power level is consistent, you know, that kind of thing. So all in all, there are about 4 different processors on our design. The blue, which is the data plane doing all the packet switching. The orange, which is where the network operating system will be running on the x86. The kind of the orange color on the left side is the housekeeping BMC. And last but not the least is the green, which is the IDT digital phase lock loop as a supplement to the timing of what we are doing. All right, moving forward, we just talked about the AX. Now we are moving into the UX. These are 2 brand new boxes that we have built, and they are actually going into mass production as we speak. We are shipping this in volume starting in later part of June. So we have 2 boxes here. They've all both based on the Crewman UX. And UX actually has different things on the different member of the UX. The top one we are showing, the -28, that one is based on a UX with 128 gig throughput. The bottom one is a different, smaller version of the UX, which is at 64 gig. So the top one is on 128, and the bottom one is 64. Now, looking at the picture, pretty much the design layout the design and the layout are the same, and the port density are different. The bottom one has a smaller density. In parallel, they are very similar to the same design philosophy as the one that we just talked about from the left with the power supply. And then to the right-hand side, after the power supply, we do have some timing support with some SMA small miniature connector. And then after that, we have different types of, 100 meg, 1 gig, and then 2.5 gig type of connection for different type of BBU connection. And on the far end, we do have the uplink for the Metro Ethernet connection that goes into the central office. On the timing design, the output is pretty much the same. We continue to support GPS, clock, time of the day, and all that. The only thing I want to point out to the audience is starting from our UX design, we actually moved to a different type of timing support using microchip, micro semis. And we are no longer continue with the broad PTB from Broadcom. And that the decision was made mainly because of the financial and the licensing reason, and not because of technical reason. Microchip has a more user-friendly licensing model, so that we can leverage that into our design and continue to keep our pricing to be very affordable for the tier 2 and tier 3 versus Broadcom has a different pricing model. All right. So moving into the block diagram, this is the larger version of the UX known as the 128 gig. And again, we continue to color code just for continuity. The blue one is our design of the data plane driven by 128 gig of the Kurman UX. And then the control plane is the Intel x86, the Davenport. Other design are very similar to the one we talk about with the AST processor for the housekeeping. And the right-hand side is the timing design. And in this timing design, because it's the microchip, micro CME, so we actually move the servo of the timing from the original data plane on the Intel chip into a different processor for the servo calculation. And in this green block diagram, we actually introduced FPGA for data conversion, because we had to, once the servo on the timing calculation is done, we depends on the FPGA to convert the data format to feed it back into the Broadcom UX. So the data format will be consistent. And that's really what the FPGA is done on this daughter card. And we have planned to keep the daughter card to continue moving forward with our other designs. So this daughter card of the timing design will be very portable for future product we contribute to OCP. So this is a huge investment at UV Space. And then last but not the least, this is the block diagram for the smaller version of the UX known as the 64 gig. The other one is the 128 gig, and this is a 64 gig. In similar fashion, we have the data plane in blue, the control plane in brown. They are pretty much the same cookie cut. And then the BMC processor to do all the housekeeping, RPM on the fan, and LED type of housekeeping. And again, I want to re-emphasize the daughter card on the timing. We call this the NTM network timing module based on the microchip, micro semis. And then we kind of talk about the FPGA there for the format conversion, because the servo is no longer being processed inside the Broadcom chip. They are in the x86 processor. So when the servo calculation for the timing comes back, we feed it into an FPGA chip to do data format conversion that will be recognized by the Broadcom synchronized the SYNC-E and other requirement. So that's what this investment of the network timing module. UV Space invests quite a lot of resources into this, resulting in future product development that we can make the PTP timing to be extremely flexible and also portable. So to sum it up, we have talked about 3 boxes today. On this diagram, we have 4 boxes, including the original one on the upper right-hand corner that we contribute 18 months ago. We want to show the heat map of the density versus the speed on the positioning. So other than the one on the left upper corner, which is kind of like the high-end version for a lot of the tier 1 carrier, today we talk about the respin of the Crewman AX right in the middle, known as the -22XST, and it's based on the original Crewman AX design, respin at a lower port density. We also introduced 2 more boxes to OCP audience using the UX, the Crewman UX, which is the lower end chipset from Broadcom, and we designed with 2 different port density. The higher one called the -28 and the smaller one called the -18. And then they support different type of port density for different type of BBU type of connection. But the key takeaway on the bottom half of the screen is the redesign of the PTP timing. Now we are using a daughter card plug-in using the microchip micro-SIMI solution. And moving forward, the network timing module daughter card will be very portable with our other product that we plan to contribute to OCP in the near future. So in summary, this is a comparison chart with all the cell site gateway devices that we have contributed and we are contributing. The blue one on the left are the one from the original OCP contribution from UV Space. The 3 blue one are the one that we are talking about today. We have decided to put all these in one at a glance kind of table to categorize the type of ASIC, different type of Broadcom chipset, AX versus UX, the type of control plane, which is the different Intel CPU, the different port configuration with the different optics, the timing support, and then last but not the least, about the special features such as the layer 3 IPsec versus the layer 2 MACsec. And in conclusion, what we are doing is to continue to adapt and follow the OCP leadership by our continuation of the contribution. Today, we contribute 3 boxes, 1 from Crewman AX and 2 from Crewman UX. And in continuation, we plan to complete the design package that we will submit to OCP as part of the official contribution, including some of the information that we listed here as the Gerber files, the PCB schematic files, and things in that nature. So we are, after the presentation today, those are the things that will be our next thing that we plan to submit onto the OCP to look for OCP accepted with the 3 disaggregator boxes that we talk about today. All right, I'm going to pause here. If anybody has any questions that I can answer, and also like to open up, we have a couple team members from UV Space, from product marketing, also from business development. If anybody has any question for us, or our marketing team, if anything anybody would like to add. So I'll pause here for a second. Okay, great. So I guess, yes, sir.
Yeah, just thank you very much for the presentation. It sounds like you're ready to contribute the files. I assume the next step is to take this to the IC committee for final approval?
Yes, correct. Yes, yes. Andrew, do you, since you are online. Can you share like approximately on the contribution schedule if you have any update from your end?
Yeah, the specifications we can send that in right after this presentation. The design files we're currently getting them all sorted out together. So that will probably take a little bit of time, but I'm sure we can. Well, I'll let Michael know once that's all done and ready, and then of course we'll upload it to the portal.
Great, thank you, Andrew. All right, that's our sharing today. Anybody else has any question for me or Andrew or other UV Space team members?
Just one question. So in your original design, you used IDT for
Yes.
timing PPLO. And for all three of these new boxes, you're using microsemi, or is it only on the low end?
Only on the low end. So if I come back to this picture here, these are the AX design, and the original one we contribute to OCP in 2018 for Broadcom Broad PTP, and because this one is a respin of that one, so we continue to use the same Broad PTP. Only the low end, yeah, only the low end we use microchip, microsemi, and in a daughter card in a portable approach.
And so does part of the contribution or part of the design actually use the microsemi PTP stack?
Correct.
And that is not included as part of the product, right? That's enabled for customer to purchase separately or purchase as part of their NOS, right?
The hardware, the daughter card actually is planned to be shipped with the box itself, even though it's a network timing module. But we do plan to provide that as including in the solution, because we are finding out working with carrier in North America, South America, in Europe, and also in different part of Asia. Timing seems to be very critical for this aggregated cell site gateway. So we make it as a daughter card, more or less because we want the same timing design we have invested that can go into many other future product platform. So we can, continue to use the same design with microsemi, right? And that was more the design philosophy. So to answer your question, the low end one with the Chroma UX, we do plan to ship with the network timing module, the daughter card.
Okay.
Yes.
But the actual so the question, I guess, is the actual PTP stack is going to be running on the host. Is that
correct? Correct. Yeah, you're exactly right. The servo, correct.
Okay. Yeah, and the question comes from the fact that I know that there are some, other commercially available modules that actually include running the PTP stack on a removable module, right?
Mm-hmm.
And so part of that discussion is, yeah, what you're offering is a module that's got the hardware on it, but the actual software stack's going to not run on on that module. It's going to run on the host processor.
Correct. Yeah, you're right. So when we work with a NOS developer, yeah, they still had to develop the PTP feature. Yeah, you are exactly correct.
Okay.
All right. Well, thank you very much. We really appreciate the opportunity for UV Space to come in and spend 30 minutes to share our upcoming contribution. So we appreciate the opportunity.
Yep. Thank you for doing that. I guess we'll be looking for Michael to confirm that you're ready for IC, and we'll review the rest of the documents at that point in time.
Exactly. Yeah, we look forward to that.
All right. Any other any comments, Michael or others?
Nothing from me. Thank you guys. Appreciate the team over at UV Space as always.
Thank you, everyone.
And, thanks for Lauren for being up.
Yeah, that's right, Lauren. thank you for staying up in Taiwan. I didn't realize you're in Taiwan, so I really appreciate it.
Yeah, I'm here, but I arrived, let's see, right before they shut down people coming in and right when they locked down everything and everybody's working from home. So I'm working
All
from my apartment.
right. Okay. All right. Well, at least you had Uber Eat.
This is true, and at least I get to go out and go for walks and bike rides and stuff like that. So it's
Great.
better.
Great. Great.
Anyway, thank you for your time, and I think we'll close out the session for today.
Okay. Thank you. Thank you all. Bye bye.
Thank you.
Bye-bye.